Hello everyone. So in this video, I'm going to show you how we can build up a very simple, very basic hydraulic circuit using Automation Studio. So right now we're in the Automation Studio stage, and just quickly a brief description of what the interface is all about. So there's a Home tab, Edit tab, View tab, and a Simulation tab. Then we have other tabs like Fluid and Tools tab and so on. On the left side, by default, we will see this library, and in the library there are tabs for hydraulic and pneumatics, and then there are some other tools used for different kinds of simulations. And then right below that we have the once we select one of these tabs, the corresponding components will be shown. So this software is really simple. It's kind of you drag components from this library and put them on the stage just like that, and then the next one you do similarly, and then try to connect them by putting them side by side. Okay. So it's a simple, very, very simple interface, and you can always learn by doing. And in this one, under the View tab, I have unselected the connection ports. So it's not showing the connection ports, but if I select it, then you see those empty circles. These are all connection ports, meaning that this component, the pressure relief valve, has been connected here with this pipe. The pump has been connected to this line. The flow meter has been connected to left and right to the pipes and so on. Just for a little bit more clarity, I removed, oftentimes after I finish building a circuit, I remove those ports from the stage, so we don't have to see those things, and we can view in a more clutter-free way. So today my goal is to finish building a similar circuit like this one, and this one has a tank, a filter, a pump, which is run by a motor, and then we have pressure relief valves. So I'm going to unselect that so it's better to see. There's a pressure relief valve as well, set at 500 psi. So all these three components, the tank, the pump, and the pressure relief valve, together with the motor and the filter, is confined in this dotted box, which I have drawn as a rectangle. Just to show you that this all components combinedly called the HPU, which is the hydraulic power unit. The box necessarily doesn't do anything, just to tell the audience that these are the components that are part of the HPU. So when we buy an HPU, we actually get all these things packaged in one single unit. Okay, and inside of them, we know there will be a pump, there will be a filter, there will be a tank, a pressure relief valve, and there's an electric motor. Right after the HPU, we have a flow meter to measure how much fluid is passing through this needle valve or variable flow controller. Right after that, we have a directional control valve. There are many types of directional control valve. They switch the connection between this line to this line or this line, depending on which way we want to move the piston. And that is our cylinder and the piston. And there are many different designs, many different builds for the cylinder, just like most of the other components. This is just one version, and I'll show you step by step how to build the cylinder exactly like that. Some features of the cylinder can also be posted on the stage if you want to. So all these labels and numbers that you see on the stage are deliberately made to show, made visible to the audience. They can be hidden as well. So, and then there is some MI, which is short for a measuring instrument. I have deployed one measuring instrument here to measure the rod speed when we do the extension or the retraction. So we'll come to that later on. Right now, our first goal would be to build up a circuit which looks just like this one. So to begin with, I'm going to have to go back to the library to get certain components, and I'll first bring a tank. So I'll take the tank. If you keep your mouse on certain component for some time, it shows the a larger view in the pop-up. So this is the hydrostatic reservoir. So I'm going to bring one by clicking it and dragging it onto the stage. There you go. If you click outside to deselect, then you see there's a tank. Okay. And then the next thing I want to bring in is the filter. If I look further down, there's our filter. I can bring one filter into the stage and they connect automatically. So right now I'll open the port view so you can see how they connect. When the ports are not connected to any pipe or any other component, they colored red, and when they're connected, they become black. So the black color will tell you that you have put them nicely. If you wanted to disconnect, you just have to select that thing, press Shift on your keyboard, and then drag it to elsewhere. And then you see both ports now became red. So if I now join them again, right, like that, and leave the mouse button, and then it just connects. Now, this one looks a little bit smaller than this one because I changed the size of this thing, which you can also do. So you select that thing, and then you have to unlock each components are locked for their sizes. So if you press that, this becomes unlocked, and now you see those marquees around this rectangle, and you can actually change the size of the component to whatever you like. And whatever you do, the connection will follow you, so it will not get disconnected while you are doing that. So bring that back to where it was, just something like that, and then it looks much more similar to this one. Next, we have to put the pump on top of that. I'm scrolling up to find the pump, and this pump has a shaft with it, just like this one. This one doesn't have a shaft, but for simple circuits, you can also use this one instead of that one, because for that one, you will need to have a motor to run that pump. So to keep similarity, I'm just going to bring this one up and align it, and then release the mouse button. And now there are two things that are red. So two things need to be connected to this pump in order to complete the connection. So this one is a rectangle, a red rectangle. It is seeking for a motor that is also going to have a red rectangle to the right side of this motor. So if I press the Shift, drag it away, it will be disconnected. And now you see the symbol of the motor looks like this. So I'll press undo, Control Z. So now we have to look for some symbol like that. And to get that, you have to expand the hydraulic tab, then pump and amplifiers. And now the corresponding components are shown here. Many different types of things that can run a pump, or even also the pump itself. So here's the component that looks pretty much like that one. It is the motor. It also sometimes called referred to as an engine. So I'll get that. If you leave that on the stage, it's red because it's looking for another red rectangle. So if you bring it close, and then they just connect. It's very intuitive, very simple. It doesn't require any practice to get things done here. Everything is very, very natural. So now that we have connected the motor, we're going to proceed and find a pressure relief valve that can set the system pressure from the library. So go back to hydraulic by clicking here, and then look for a variable pressure relief valve. reducing valve, relief valve. So these are two different things. So you have to be very careful in choosing what you are picking. That's the variable relief valve. And I'm going to select that one, pull it over. So it looks like that these two have different phases of their turning. So I'll just have to turn it clockwise by 90 degrees. Go to Edit tab. Here's the position. You can turn them by how it looks more like that, but it looks like that the spring is on the right side on this one and on the left side on this one. So you can flip it about the vertical axis like this one. And then you see it looks all the way. It looks exactly the same as this one. Now I'm going to bring it down. And here you go. You can set different pressures on the spring as shown by the inclined arrow. So I'll finish the connection a little bit later. Sorry. Before I do that, I'll connect the other components. The flow meter measures how much flow is flowing through a pipe. We have to look for most of the thing, 80 to 90% of the thing you need to build a basic circuit should be available in the I call it the home page of the library. So whenever you click on the hydraulic, this is the page it shows you, and most basic components are always available in here. So I'm going to pick the flow meter, leave it on the stage, and it also comes with a display that is now showing 0 GPM, that is gallons per minute, because it's not doing anything. There is no flow in the system yet. So now we have to turn it. Let's turn it by 90 degrees, and now it becomes like this. And this one we can also connect just like that. And we'll connect this. Now, if we just simply click once, it will not connect. So you have to double click to make sure that there's connection. So the hollow circle and the solid circle, so they're different. If you see a black circle that is completely solid, it means it is a node that it has more than just 2 connections. It has 3 connections. And when you have only connection between 2 pipes, 2 open ends, you see a hollow black hollow circle. So every color, every feature of these components means something. You just have to know what do they mean. Now this one, because it's a dumping device, the pressure relief valve should be connected to the hydrostatic reservoir or the tank, and that's how we do it. And now we have completed our HPU. So we can draw a rectangle like this. You go to the Home tab, pick the rectangular tool, and draw a rectangle around all the components that are actually part of HPU. Release your button. And then to get rid of this cursor, which is changed now, press escape button on your keyboard. There you go. And then you have this rectangle. Now it's solid, and this one is broken. So I'm going to select it again, go to edit, and drop down list. I'll pick one that I like. So let's say number 7 and deselect. It looks like we got what we wanted. So here's our HPU. You can actually label it by picking the text tool. Here's the text tool. I do all the labeling at the end. So just click on the stage HPU, I write in uppercase, and then escape. And you can also change the size of this thing if you wanted to. And there you go. That's your HPU. You can put it anywhere on top to say that this is our HPU. Now we finish the connection by bringing a needle valve here, a flow control valve. So if you look in the home page, there's our needle valve. But you see there's a slight difference in these two. This one looks like it has an additional arrow here. This one, even if I turn it, let's say I turn it clockwise, now they're more similarly aligned. Now this line has an arrow here, this one does not. And it means something is different between these two. And the thing is This one is a variable flow controller. You can change the flow by reducing the diameter of the pipe. This one, on the other hand, you can reduce or increase the flow directly by changing the GPM value. So this one gives you a more direct way of controlling. This one gives you an indirect way of controlling. I prefer this one because that I don't have to iterate or I don't have to fiddle around to get to a certain flow rate in GPM or RPM with this one. But with this one, I have to change the diameter correctly, precisely to get to a certain value that corresponds to that diameter value. So I will look some more to get the exact one that I need, but that is not available in the home page. So what I have to do, because it's a flow controlling device, I'm going to have to go look for it. Flow lines and connections, flow valves, because it's a valve, I have to look under the right tab. So that's our flow valve. If I expand this one, it's not here. Orifices, flow controls, and looks like we have our guy here. So flow, variable flow controller. I'm going to bring that on the stage, turn it by 90-degree clockwise, and now you see these two are exact match. So I'm going to delete this one, and I'm going to bring this one close to this flow meter. Here we go. Our next in the list is the DCV, or the directional control valve. I'm going to go back to the home page by clicking hydraulic, look for the DCV, and looks like this is the one we are looking for. If you see the enlarged view, you see that's our valve, right? So I select that, bring it onto the stage, let go of the mouse, and this one needs a turning clockwise 90-degree. And remember, this device component has 4 open ports. You have to connect each port to a designated component. All the fluid from the pump is going to come and arrive at this point. So I have to connect the DCV's first port to the needle valve. Now they're black. This one has to go to the blind side of the cylinder. This one has to go to the rod side of the cylinder, and this one has to connect to the tank. Okay, so we'll finish the connections. You can use multiple tanks in a circuit, or you can use single tank and connect everything back to that. Or this is one way of doing it. The other way, to delete this line, let's delete this line. The other way would be to have a separate tank for this one from the home page, and you can also put it right near that and let go. So this is another way of building the circuit. No matter how many tanks you have on the stage, they all refer to one single tank in the system. So from a simulation point of view, it will not create any different results. It will just make it more discrete, but had you choose to do the other way around, so if I press Ctrl Z several times to get back to where we were, if you prefer to do it like that, it's more compact, and you're not using too many symbols on the circuit. But you can do either way. That's not a problem. Now we're going to build the hydraulic cylinder. It's a double acting cylinder that has this stroke length. So from this point to that point, the length of this cylinder is 3.93, and the rod diameter, this guy here, is 0.44 inch, and the piston diameter, this one here, is 1.5 inch. Okay, so if I want to build a similar cylinder, I have to start with the home page. So this is a double acting, this is a single acting, this is a single acting with spring. I'm going to pick this one, drag it onto the stage, place it little close to the here, something like that. The default size is pretty small as compared to that one. It doesn't really mean that this one is a shorter cylinder. So if you double click any component here, it will open up its property window. I'm going to double click on this one now to see what property we can play around with for a cylinder. So double click, and here you go. That's the property window. I'll leave that side by side. So inside, there are many tabs: data, force curves, builder, variable assignment, accessories, troubleshooting, and all those things. The default tab that will be open for you as soon as you double click any component is this one. And this one has all the engineering and technical values. For example, the extension, inclination, if the cylinder was placed at certain angle alpha, that you can also put it here. So unless you change anything, the symbol just not going to bother. So if you change the piston diameter from here, which is 3.937 inches, nothing will change here. Although these two looks different, their stroke length, this one has 19.68 inches, and this one has 3.93 inches. Actually, this is shorter than this one, but visually it looks very longer than this one. So what I'm trying to say, the visual aspect or features of the symbols are not going to affect the simulation. The simulation is only going to listen to whatever value you have written down for their property. So what matters is these numbers, not how they look. Okay, so but for the sake of similarity, I'm going to make this a little bit longer looking, so it's look like this. Okay, so to do that, you have to go not in this tab. We have to go to the builder tab. But before we do that, I have to make sure that all the numbers are matching with this example, right? So this is a stroke length of 3.9375, 3.9375. The 5 is not here, but anyway, we can assume that if you hold your mouse there, so 3.9370, so we can change that here, 75. There you go, press enter. Now our stroke length, sorry, that was the piston diameter. I changed the wrong thing. Okay, so we'll do that. Stroke length has to be 3.9375. Let's do that, 3.9375, enter. Now we change the stroke length of this one to match the stroke length of this one. Rod diameter is 0.4375. Rod diameter is here, 0.4375, enter. And now the piston diameter is 1.5. There you go. Now everything we have for this one exactly the same as this one. Okay. Now we're going to make it look like the same as this one. So go to Builder tab, and here's your cylinder and piston. Looks like this piston has cushion on either side. So if you double click on any of these properties, you can pick which one you like. So that's the double cushion. And okay. And at the end, it has two adapters. So I'll have to click here, double click, and I can pick whatever adapter I want. It looks like the cam type 2 has been chosen. So now it is starting to look like this one. And now we have to make it longer than that, right? So click on the body, and now you see it has a certain value to put. I'm going to put apparent length. So that's the apparent length. That means it's not the actual length of the stroke, it's just apparent length. So I'm going to pick a number 5 from here. I hope that this one also has 5. Now I finally press OK to save everything, and you see is immediately reflecting whatever values we have. So the visual aspects are now same for the bolt, and now I have to make a connection. 2 red dots has been connected, and these two, I'll try to make it look like the other one, and now we're connected. So that's our directional valve. That's the cylinder. I left some space here so I can put all these labelings there when I show you how to do the labels. You can actually get rid of this thing for now. by selecting and pressing delete on your keyboard. Now you see our circuit is starting to look pretty much similar to this circuit. All we have to add is the measuring instrument to our thing, and we have to make sure that all the numbers are equal, the parameters are equal. So to do that, I have to go and check their property of each component. These ones are default for the filter and the tank, so I will not touch them. For the motor, it says 400 RPM. I'm going to double click on our motor and see if we have it right. That one is set at 2000 RPM. So I'm going to change that to 400. And when you click on these check boxes, it is meaning that if you want to show this property 400 RPM on the stage, you'll have to check this box. So if I check this box, you see 400 RPM is shown here. You may have to do a little bit of adjustment to bring them where you want them to be, like I did here. So we'll do that later on. And there you go. So you can see the 400 RPM. And if you also want to show the name of this component, which is the motor, here I don't label it. I didn't label it. Here I labeled it as motor. So you can also do that. So component name is the checkbox you want to click, but you don't want to write engine. You want to change that to motor. So there we go. That's our motor, 400 RPM. We will do some switching around to make them look like this. Next, you want to cross and come out of this thing, and then do the same for the pump. So double click on the pump. I'll move this a little bit to the side. The component name I want to show, but not that big. I want to, okay, now it's time for us to actually move it around. Then select this pump again, and it populates the one that you have selected. So I'm going to delete the other wording and only leave the pump alone. Now, if I press enter, it is now just the pump here. And for the pump, it's important most of the time to mention the displacement size, how much fluid it can displace per revolution. So we'll click this checkbox, is 6.1 by default. I won't touch that. I'll just bring it here. And I'll also bring the label pump. Looks like I cannot touch it anymore. So go back to the pump and write something. So it becomes longer, and I can grab that there. And now check the pump again and get rid of the, let's say, debris, right? So there you go. The pump is here. The size of the pump or the volume displacement of the pump is here. Now, since things are becoming a little chaotic here, I'm going to start organizing them. So to do the organizing, you select two of these things by pressing the shift button, holding the shift button, and clicking on the text that you want to bring close together. And then you can change how they are formatted like this, and then go to the align left, and they will be aligned to one another. And you can also bring them close to each other, and then rather do the alignment, align left. Now they are like this. You can change the size so that it doesn't look very congested here. So there you go. We have, oh my gosh, so this, yeah, sometimes it's really messy around. Yeah, so I'll leave that not to make the video super long. So, and the pump and this also make them size 7, align them to the left, and then bring them close to one another, and then do the alignment. That's better. Align left and pull them up here. So we're beginning to look similar to this one now. This one is the filter. This is the tank. I will not label them to save some time. Now, you can also show some real-time values like this relief valve. I'll set it to 500 PSI, for example. Okay, so I'll first do the relief valve, right? Labeling. So that's the relief valve now, and I'll bring it down here, and now select the relief valve again, and this is the pressure or the cracking pressure. Check the box here. The cracking pressure now is 1160. We need 500 psi. If you look in our example, this is how I can. So these values are going to affect our simulation, and enter. So we have 500 psi for the relief valve, and now I'm going to select these two texts, make them formatted the way I want, align to the left, and change their size to size 7, and that's it. So that's how we do the labeling. And as the final step, you would also like to show all the how, as a final step, that would be our simulation there. So we want to run the simulation by going to the simulation tab and play a normal speed simulation. And from the simulation, we want to gather certain experimental data. Okay, so once this extends, we want to know how fast it is extending, or we want to know how much fluid is passing through, and so on. The other variety of parameters that we can actually extract from a simulation. So before we do that, I'm going to double click on this cylinder. The property of the cylinder is now shown. I want to show certain things, including the double acting cylinder, the name of this component. I'm going to bring it over here. Double acting cylinder. Let's select the cylinder again, and now I can see their properties. I have already changed these values, so let's show all of them. And when you select just these numbers, they don't show me these values. These are aliases. If you want to also show their aliases, like the labels, the name of the variables, then you can also click here. You can normally don't see this, but if you select one of these things and then show details, you can see their alias is unchecked. You can check it, and now you see the stroke is appearing here. This one is the rod diameter. So if I go to rod diameter and display alias, you see the rod diameter is now showing nicely aligned and so on. Similar for piston diameter, I'm going to display alias, close this box, and select this 3. And now I'm going to select this one as well. All 4 texts are selected. Go to edit, format them, and select a smaller size, say 7, and then align them left. And now they all pretty much looking like our example, right? And yeah, pretty much I left out some of the labels just to save some time to make the video shorter. Now, if I only try to show this one, I have to run the simulation. I can do that by clicking this box. Now, once I do that, you can see the fluid is moving into our circuit. This pump, under simulation, you can also click each component, and maybe some of the component will show you something. Like if I click on the motor, it shows a dialog box that can enable you to change the angular speed, or omega, to a different value. Right, I'll leave that to 400. Similarly, if I click on this one, you can see I can change the internal volume of the pump. I can also click on this one. I can change the spring tension to different values up to 6,500 psi. So these are the things you can change. And this one, if I click on the flow control valve, I can select how much flow I want to pass through this. No matter how much the pump is pumping, the pump may be pumping 10 GPM, but I only want to allow 3 GPM through here. I can change that from here. So it can go as low as 0, as high as 110. So whatever you prefer, you can select that here. So I'll close this for now. And the DCV, you can select different positions. This is the closed position This is the open position, so that's will cause the extension to happen on the cylinder. This will cause the retraction to happen on the cylinder. So if I do this, let's bring the thing to 1 GPM, enter. So things are not super fast. So I'm going to move the DCV to this position, and you see the rod is extending. And if I do this, the rod is retracting. So this is called extension. This is called the retraction. Now it's happening really fast. Sometimes because the flow rate is really 1 GPM is really high, and pressure is really high. The pump is pumping really a lot of fluid. The motor is at a considerably moderate speed. So that all contribute to the fact how fast this thing is going to move in and out. But to get a quantitative idea of how fast things are moving in the simulation tab, you cannot do it when the simulation is stopped, like here. To be able to do that, you must run the simulation and go to the simulation tab. Under the simulation tab, measuring a block. So this gives you option to measure things like pressure, like this one looks like an icon of a cylinder. This one actually gives you to measure certain things around the cylinder. So I click that, and immediately my cursor has changed. You see the cursor now is looking different. I'll bring the cursor over anywhere on the cylinder and make a single click. And now you see the cylinder has changed its color. That means I can change, or I can read certain parameters, certain variables, or certain reading off of this component using this cursor. If the color would not change, that means that cursor or that measuring instrument is not going to work on that component. So you want to do a second click, not a double click, second click, and don't leave the mouse button. So I'm going to do a second click, drag the mouse button without leaving the left button of the mouse. So don't unclick it. Keep the pressure on the left button. Now, if you move your cursor, you see a line is following you. It is wanting to know where you want to place the value of the readout. So if I release the button here somewhere, you see it gives me measuring instrument number 12. This is simply because I have used up 11 other before this one. So the number doesn't really matter. At the same time, it's popping up with a form asking you certain questions. So what do you want to measure? It has automatically guessed that you want to measure speed because I clicked on the cylinder, but you can choose to measure something else. So you can choose to measure whatever thing you possibly can from a cylinder. Okay, so I'll leave that to the cylinder linear speed of the cylinder or the rod speed. And what unit would you like to measure it in? I'll leave that unchanged, inch per minute. What kind of precision do you want? You can go really, really precise value or just an integer, okay? And then I'll just select OK. And there you go. We get the value in 0 inch per minute because the piston is not moving right now. To get rid of this cursor that you can see, simply have to press the escape button on your keyboard. There you go. And now you have the cursor free. Okay, right now we are now fully retracted. If I go and select this block, you should be able to see some number here. 129. Again, I'm going to retract 141. So you see retraction is a little bit faster than extension. 129, 141. So sometimes you will see different values while the piston is moving. Okay, if you see different values, you want to take the value towards the end of the stroke. So when the piston is extending, you want to read the value corresponding to the piston when the piston was nearing this part. Okay, so it's 129. Although it begins with 140 something, you can always pick the value at the end. Also, for the retraction, don't take the value as soon as it starts. Rather take the value towards the end of the stroke, like 141. So retraction speed is clearly 141 when you have a flow rate of 1 GPM. And you can also display the flow rate in real time because you have the component for the double click the flow meter and the flow value here. You can select to show all the time while the system simulation is going on. I'm going to change the size of this thing to 7 and then bring it a little bit close to the component. There. So now if I go back to the simulation and I want to see how much fluid is passing through during extension, I can do that. So I'll click this one. At the same time, I'll watch what is reading. So it's 0.98. Remember, we set 1 GPM here. We are not getting 1 GPM, but very close to that. Okay, so if I retract, again, very close to 1 GPM. That's normal, that's okay if you see something different, but when you see significantly different, then you know that there is leakage in the system. But the simulation tries to give you a real picture of what happens in real life. That's why it doesn't give you the 1 GPM. It considers certain amount of fluid being lost through leakages and maybe sometimes partially dumping through the relief valve. That's why even if you set 1 GPM, you don't actually get 1 GPM in the blind side of the cylinder. You get a different value. Now, sometimes reading off it could be very challenging. Let's say if I have a flow rate of 2 gallons per minute, enter. What do you expect? The rod speed is going to be faster. Okay, so let's do that retraction now. It's really fast. Now, extension, also very fast. Sometimes it's crazy fast for a human eye to read the value. Okay, so to overcome this challenge, so extension is 259, retraction is roughly 283. To overcome this challenge, you can actually switch to slow motion simulation as opposed to normal simulation. I click this one. Now the simulation is still running, but everything has slowed down. Okay, so the pump, you see, it's slowed down. Everything is happening in real speed, but for the viewer, it is appearing slowly. Okay, so I'm going to click this block here to show the extension one more time. And now you have plenty of time to actually watch what is happening. Again, keep in mind, you want to read off this MI block towards the end of the stroke, not in the middle or in the beginning. Again, I'm going to do the retraction. Watch carefully, this block and this block here. It's 283 and the flow rate was roughly 0.98. Okay, so this is how you build up a basic circuit and run a simulation. Now, last but not the least, the colors in the circuit tell you something. If you see red color, those lines are filled with high pressure fluid. If you see blue color, those parts of the pipes are connected to a low pressure fluid, which makes sense because this is the tank line. Every fluid, everything in this pipe is at the atmospheric pressure, which means anything that is at atmospheric or low pressure should be shown in blue. This part, because this is now disconnected from the pump line, you see, if you choose to use this block, this line is disconnected. So the fluid is at low pressure here. But this part of the fluid, although it's disconnected, it has been trapped here because we just finished the retraction. And then during retraction, high pressure fluid was moving from this side to the rod end of the cylinder, and they could not get out when the retraction phase finished. Similarly, when I do the extension, you'll see the opposite. Red color in this part and blue color in this part because during extension, the pump was connected and now this fluid is trapped. If I go now to the closed position, this fluid cannot release the pressure because it was never connected to the tank throughout the stroke, okay? But this one was always connected to the tank. So even though you disconnect that, the fluid inside that is now trapped is still in low pressure. So sometimes you will see magenta or green color in some parts of the pipe. Green or magenta represents negative pressure or lower than the tank pressure. So if you see that, that often can be connected to a problem in a circuit. So if you see those two, one of those two colors, green or magenta, you know there is something wrong in your system. You have to try to troubleshoot and then try to best fit to the reality. Okay, so other things you can use to measure whatever is going on in your system is pressure gauges. So I stopped that simulation. I pick a pressure gauge from the homepage of my library, and I want to put one gauge here. I want to put, you can use as many gauge as you like. So I can put one more here and then run a simulation. And you see our system pressure is set to be 500 psi. Okay, and you see that pressure is shown here, also here. So pressure mostly is accurately maintained, but as you go elsewhere in the circuit, like downstream side of the circuit, you will find less and less pressure. So for example, I take one more and I want to connect it here, and I want to take one more and I want to connect it here, you won't see the same thing now. So although this line are pressurized because these are all red line, it is 500 psi as directed by the pressure relief valve, but these ones are showing much low pressure. This is 0 psi, this is almost 0 psi, and so when you switch to retraction, the scenario will be changed. They probably will go to higher pressure. Now you see this is during retraction, and this line is now pressurized, and this line is at 0 psi. This line is also almost at 0 psi. So you can use different other components to do different things in your circuit. So I won't make it longer. So if you have to simulate certain experiment which you have done in a lab setup, you want to make sure that some parameters like here are the same as what you used for your lab, and then using those parameters like the pressure, like the RPM, like the volume internal volume of the pump, like the RPM of the motor, like the flow rate in the through the needle valve, and the pressure relief valve pressure. These are the parameters you want to make sure that are the same in your lab experiment as well as in your simulation. Then you can compare the outcome of the simulation to the lab experiment. And there will be some discrepancies, of course, because the leakages we consider here are minimal. It takes the highest standard of a lab setup in mind to produce these results, but these are more like theoretical results. What you see in the simulation, whatever you're going to see in the lab will be way different, but that should not worry you, because lab experiment is not meant to produce 100% accurate results. They're meant to learn, they're meant to experience what actually happens in a lab setup, which is way different from theoretical or simulated results. But that gives us an opportunity to compare, but from fair comparison, we have to make sure that the boundary conditions like the relief valve pressure, the size of the pump, the motor speed, the flow rates, these are all kept to equal values. So then only our comparison will make any sense. Thank you for watching. I hope this will be helpful. And in the future, I'll make videos that are on much more moderately complex or a little bit more complex systems. This one was a very basic one, but I hope that this will give you a good start and hope you will understand this. Thank you very much for watching.